Okay. Good morning, everyone. Thank you very much for the introduction, and thank you to ILSI North America Food Micro Committee for bringing together this session. I know there's many people out there who have a lot of experience with process validation. So this morning, what I'm going to try to do is to just present an overview. So the first time I put this together, sorry, I had about 50 plus slides, and I said, this is not going to work for a 20-minute session. So I thought, well, okay, what would I tell somebody if they came to me and said, how do I validate that? And so I put together a little presentation for this. Let's see. The first thing I would do would be to tell them what is the purpose and the food safety context of the validation study. And then I would take them through a couple of steps. So what is the tasks that you need to do prior to your validation? What do you need to do during your validation? And what kind of documentation do you need? And what would be the components of that documentation? Lastly, I'd go through with them some pitfalls that they might encounter. So I just wanted to make one caveat, and that is that I'm not going to talk today about verification or monitoring. This is just validation. There are some really good sources to look up if you need to know about how validation fits relative to verification and monitoring. The Codex does give a lot of definitions. There is also a recent paper by Wilfredo Ocasio and Bob Brackett in Food Protection Trends in November that also walks through those topics related to FSMA. Okay. So what is the food safety context of process validation? So hazard analysis and risk-based preventive controls refer to effective science-based tools and activities to ensure food safety. This preventive approach to safe food manufacturing is comprehensive and includes prerequisite programs and process control. So how do we as food manufacturers ensure that our processes are designed and implemented correctly to achieve this food safety goal? Does everyone know the answer? It's process validation. Okay. So what is the definition of validation? I took this from the Codex Alimentarius. It's obtaining evidence that a control measure or combination of control measures, if properly implemented, is capable of controlling the hazard to a specific outcome. And validation focuses on the collection and evaluation of information that's technical, observational, scientific, and how these pieces of information determine that the control measure is capable of controlling the hazard. Validation also focuses on measuring performance of the process against a desired food safety outcome or target. So when do we validate or revalidate a process? Well, I'm coming from a manufacturing perspective, so this is how I see it. It's either R&D ingredient innovations. We might do it for process optimization initiatives, some market changes, new scientific information, the emergence of a new hazard or higher risk of that hazard in the product, some regulatory changes or perhaps consumer complaints. And these will all lead to what internal process changes, either a new equipment or a reconfiguration of current equipment, product formulation changes, for instance, if you want to change the water activity or the moisture or the size of your product, if you're taking out salt to reduce sodium. If there's a new process, whether you're lowering the temperature to decrease energy use or speeding up the flow to make more product. If there's a new hazard or some new technology defined, that's when you would validate. So the first task is, the first step is to look at the task performed prior to validation. It's very important. This is basically, where do I start? And to conduct your validation effectively and efficiently, you have to do some really good background research. So you might want to start to look at product recalls. Look at the Journal of Food Protection, look at the FDA database. There's also some really great global databases to check out food recalls. You might want to you have to look at your product intrinsic characteristics. Do you have high or low pH, high or low water activity, and what is the moisture of your product? You want to look at your process parameters. You want to consider all options of processing this product to control the hazard. And it's good to go through journals as well for that. Are there previous risk assessments for this product and process? Do you know who the experts are? And can you go out and reach out to those experts to see what those risk assessments are? You look in publications. You might go to Google Scholar or something to find some background information. And not lastly and not least is local, federal, and international regulations and guidance. So just take a look at this for a second. And for one example I'll do is nut processing. So in nut processing, there's kind of contrasting guidelines and regulations. The first is the Almond Board of California, which provides very specific control parameters that must be met for almond processing in the United States. And this is for oil processing, steaming, blanching, for the use of gases like propylene oxide. They also require registration with annual renewal for all U.S. facilities producing almonds. And they also require registration with annual renewal, for process authorities that review those registrations at the facilities. This is the law. This is part of the Federal Register. It was done in 2007. Contrasting is for tree nut and peanut processing. We have a great guidance document, which is the GMA Industry Handbook for Safe Processing in Nuts. This was an industry consortium that put this together, and it provides really great guidance for handling and processing of tree nuts and peanuts. It also contains a section on process validation, and it refers to recommendations for 5 log reduction. So that's something that is specific, yet this is still a guidance document. In the US, there are other regulations that you can look into, some that you're more familiar with probably, such as the pasteurized milk ordinance, those regulations for low-acid canned foods. There's a regulation for hazard analysis, or HACCP, for the safe and sanitary processing and importing of juice. The American Spice Trade Association, ASTA, has a HACCP guidance document for spices and seasonings. And then there's codex put out by the through international food standards, through the World Health Organization. There's a lot of guidance first on milk, spices, and herbs, aflatoxin control, and metal detection. Also, in the back of this document are some examples for validation, and those examples include looking at sanitation methods, looking at labeling, looking at aflatoxin control. So that's a really good document to look at. There is some examples of food categories with less guidance, and these categories are processed, but there's very little guidance for validation. And these categories include dried vegetables, coconut, cocoa bean. Those are just some examples. And then back to the tasks performed prior to validation. The next thing you want to do after your background research is to identify the target hazard or the pathogen that's intended to be controlled, taking into account all relevant information. So what did your search tell you about your hazard and its challenges? Did you look at prevalence and outbreak data? What is the severity of the hazard? Did you look into the history of the product and the use of the product? And then once you identify your hazard through your research, you need to investigate if there's an industry or a competent authority that provides guidance on the target pathogen in your product. You can consider a surrogate if applicable, and I'll leave surrogates out of this presentation because Monica is going to get to that. You must understand the characteristics of target hazards and pathogens with regard to the intrinsic parameters of your specific food material. And that's water activity, natural antimicrobials, if you're looking for validation of allergens, source of allergens, or foreign material. The next step prior to validation would be to identify a recommended process and the equipment to control the process. What did your search tell you about this? So you have to consider the potential effectiveness of the process equipment to control the hazard. Is there already out there a well-established process for your product? Consider the location of the control measure to account for separation of treated product after process. I want to say this, but these are all really big points. Location of where you put your control measure is really critical to the flow of your product. You want to identify the worst case conditions, and I'll get to these a little bit later. And you want to determine if the control step is one step or a combination of steps. Other considerations, I think it's skipped. The variability of the control measure, bed depth, how submerged does your product have to be? Is there a cold spot in your process, and do you need to know what the variability of that is? Monitoring and verification of the control step after validation. There's really no sense validating a control step if you can't monitor it and verify it analytically and physically. So if you can't reach where the validation, the control point is, then you shouldn't be using that as your control point. The variability of the food. Are you processing in Minnesota or are you processing in Florida? Does the incoming temperature of the food material make a difference to the thermal process? Does the variability in moisture make a difference? And the answer is yes. So if you get something with more moisture or less moisture and you have variability depending on the season or the location of the source of it, whether it's in California or the East Coast, what the moisture will be. Is the product have variable density? That's also very important. The size of the product, is it a shred? Is it a flake? Is it a shell? Whatever. Do you have adequate resources committed? This is another biggie. Do you have the money and the personnel to determine the process capability, to execute the trials leading to the final process, to ensure the proper data review? And it's really important to have management commitment from the very beginning, the installation of the equipment and carrying out all of the validation studies. Step 2, the validation. So with the validation, you want to define the parameters that you found through your research that demonstrate that the control measure is capable of consistently controlling the hazard to the specified target. Okay, so the first thing, you want to capture all variability in the process, and I just talked about that a little bit, but substrate variability, if you're doing metal detection, what's the sensitivity of it? Airflow, force and direction, the control point measurement accuracy, that's very also important. You want to define your replicates, make sure that you have some data analysis before you go in. Include startup and shutdown procedures. And if you're using a surrogate, quality control procedures that characterize a surrogate must be in place. Oops, okay. You want to document the worst case conditions. I can't stress this enough, but the validation must be conducted under worst case conditions. These are just examples and some that I've encountered in looking at validation reports. The time. Is the residence time or throughput has to be conducted at the worst case. So an example is validating a process at 17,000 pounds per hour and slowly, incrementally moving up to 25,000 pounds per hour, but you need to know that it's conducted at the worst case conditions. If you're looking to achieve equilibrium pH, maybe mixed time is your worst case condition. For temperature, determination of the cold spot in the process. And location of the temperature probes across the process. This has to be related to where you have determined where the cold spot is. The product initial temperature. Bed depth variations if you're using a belt roaster and you're just depositing the product in a line, you have to make sure you have a bar there to cut off different hills and valleys in your bed depth. Product size or configuration. If you're doing split nuts or whole nuts, you want to make sure you do that at the worst case. Airflow and velocity, make sure all the fans are moving, possibly do your validation with one of the fans off to present a worst case condition. And if you do mixing or submerging, make sure that your batch size is conducive to being submerged totally in your tank. Okay. We're moving on to the documentation, the components of the credible validation study. So all this documentation must include everything that you've thought about and put down on paper before you got to this point. So all your research, this should be included in it, all the worst case conditions, all the steps that you've taken, everything should be in this documentation, should tell a story about what you did, so that the next person that comes down the line can read it and understand it, so that the auditor that comes to your plant and wants to read your validation can look at it and understand it. So the story, of course, has an introduction. It has a reason for validation. And that's either the new process equipment or the change in equipment, process conditions, faster time, higher temperatures. Is it a retrofit of the current equipment, a new product in an existing piece of equipment, new scientific information regarding the process or product that changes the summary of the initial validation? The second thing, you must describe the process. You have to describe what the type of process is. Is it a steam? Is it oil? That seems pretty simple, but believe it or not, it's left out sometimes. You have to describe the processing, the target processing parameters, establishing the minimum requirements for the control point and be documented in your report. Assess the variability of the sensors to account for the safety buffer. If your sensors go plus or minus 1 degree centigrade, then you need to include that in your safety buffer. You have to describe the type, the brand, the capacity of the equipment, and it would be in your own interest to put a diagram there so that when you have a technical expert to come and run your validation, that you can look at the diagram and make sure that they have accounted for everything in your facility. You want to describe the type and location of the process sensors for variable and fixed parameters, so bed height, the flow rate, the temperature, airflow pattern, and description of critical alarms, either divert or shutdown features. Calibration practices and schedules should also be included so that you understand exactly what your calibration practices are and at what frequency should you do those. You have to describe your product. The original form of the food product, is it raw? What is the source? The intrinsic characteristics as they relate to validation and water activity. The final form of the food product, is it a nut paste? What's the water activity and the moisture? And the size and variability, or whole beans or shreds. Finished product packaging, if that's important to your validation, that needs to be included in there too. The operational aspects of the validation, you have to document your worst case conditions. And then you need to put in there the adequacy of the startup and the end of run. Your monitoring records, attach examples and completed examples of monitoring records and calculated log reduction to demonstrate the actual practices are in line with the design assessment. Replication of the process and the reproducibility of the results must be in this validation, and statistical evaluation of the results to determine the range and the variability of the control point parameters. If you're using surrogate microorganisms, understand the credentials and experience of your technical expert and require measurements and documentation of the surrogate resistance as compared to the target pathogen for this specific product, this specific process. So, in summary, the integral part of the facility's food safety plan is this validation report. It includes the requirements relative to the specific hazard, the specific product, the specific process. And the report should correctly identify the reason for validation, the hazard, the product, the process, the operational aspects of the control point validation. The conclusion should state the outcome of the experiment, the technical expert's summary of the experiment, the recommendations of the verification activities, monitoring activities, corrective actions, and documentation of the control point. Pitfalls to be avoided. I have 1 minute, I think. So pitfalls to be avoided, don't and do. So one of the pitfalls is relying on one consult for the validation. Really, you should reach out to two or more proposals from reputable technical experts to look at your validation for technical merit and comprehensive treatment. Another pitfall, lack of quality control of the surrogate and use of an untested surrogate. If a surrogate is used, it has to demonstrate equal or greater resistance to treatment on the specific product and at the temperatures used in the study when compared to the target organism. Not determining the cold spot in a thermal process. If using a thermal process as a control point, the coldest spot in the process must be documented prior to the validation study. Not validating the extremes of the formulation. The validation should cover intrinsic parameters, tolerances of the product. So if you validate at 3% moisture, don't accept a product that's 2% moisture because that will make a big difference in how the salmonella is reduced. Vague or missing description of the control point monitoring verification activities. It's important to get the control points clearly identified with verification procedures, corrective actions, and monitoring activities, all discussed before the technical expert leaves. Not understanding the science behind the control point. This is really important to understand the reason for revalidation in the future and also to avoid the extrapolation of the experimental findings to the process conditions that were validated. So in summary, basically do your homework, know your hazard, know your product, know your process. Identify the worst case conditions for your process. Retain the report documenting the validation and conclusions as part of your food safety plan. Educate yourself. When you need a validation, who are the experts in the industry and what constitutes a significant change in process? And consult with several experts to achieve your food safety goal. And you're off to validation paradise. Thank you very much.
Thank you, Nancy. We have time for a few questions. If you'd like to go to the microphones in the center aisle so we can record your questions.
Wow, I must have covered it really well.
No, I have a question, Nancy.
Okay.
You mentioned you need to reevaluate a process if you lower the sodium in the product, and I know that's a lot of activity within the food industry. So would you give us a sense of some of the amount of time that's involved? I mean, when you look at all of the steps and the preparation going through, that's
Sure.
quite extensive to undertake to reevaluate a process.
Right. So it really depends. The time it takes to revalidate a process would really depend on the process and the product and the target organism. So I'll say for sodium reduction, you might be looking at Clostridium botulinum. And to do the challenge studies for a new formulation for that would require a technical expert, a laboratory that has that particular clearance for running botulinum studies, and there's several in the country. And then it probably would take, I would have to wait for outgrowth and toxin production, and anywhere from 6 months to 9 months to 12 months to do something for botulinum sodium reduction. When you're talking something like a new roaster, the preparations might be a lot quicker. That requires definitely finding your technical expert. That technical expert has to grow the cells, bring the surrogate to the facility, run them, and run 3 or 4 shifts, 3 or 4 different days, and maybe work with some trials and everything. So that might take 3 to 6 months. Thank you.